Hey everyone, in this video we will solve a transportation problem. A transportation problem is a common optimization problem where we have one set of suppliers and one set of destinations where there is demand of a particular commodity. Now the problem is that there is different cost of transportation per unit on different routes. So transferring one unit from this factory to this shop costs 2.9 units of money, and our agenda is to find out which factory will supply how much to which shop so that the total cost of transportation incurred is least. Let me show you this example situation. Suppose you are required to satisfy the demand of certain commodity at three different shops, S1, S2 and S3, with what is available at two different factories, F1 and F2. The quantities available at F1 and F2 are 3 units and 6 units respectively. The demands at S1, S2 and S3 are 2 unit, 3 unit and 4 units respectively. As the total supply is the same as the total demand, obviously there is at least one feasible solution to this problem. Also, as the number of factories is less than the number of shops, at least one of the factories is supplying to more than one shop. So let us first put this problem into a tabular format. So on the left, I have just listed down all the constraints that I mentioned. On the right, there is a table. In this table, on the left, we have factories F1 and F2, and on the top, you can see shops S1, S2 and S3. The first value in this table will tell us how much units will go from factory 1 to shop 1. The second value will tell us how many units from factory 1 will go to shop 2. And this is the meaning of this table. Each cell is telling us which factory is sending how many units of commodity to which shop. On the right, I have written the constraints. The factory 1 has a constraint of supplying maximum 3 units. Factory 2 has a constraint of 6 units. Shop 1 is demanding 2 units. Shop 2 is demanding 3 units. Shop 3 is demanding 4 units. So basically, the sum of these two values should be 2. These two values should be 3. Next two values should be 4. And if you go horizontally, these three values should be 3. And these three values should be 6. Below, I have another table. This table is giving us the transportation cost from each factory to each shop. So if you want to transport one unit from F1 to S1, you will be charged 2.9 units of money. If you are going from F2 to S1, you will be charged 2.3 units of money per unit of commodity. So the total cost of transportation will be the product of number of units you are sending from one factory to that shop multiplied by the cost of transportation per unit plus the units that you send from that factory to another shop multiplied by the cost of transportation there, and so on. You add all these individual costs to get the total cost. To get the total cost, we have used a single formula called sum product. This formula multiplies elements of two different matrices and adds them simultaneously. Now, from these tables, you can see our agenda is to minimize this cost, and the cells in green color are our variable cells. We want to change values in these cells so that the demand of all these shops is satisfied and we get the minimum cost. Just to prove that there are multiple solutions, let us just by observation solve this problem. Let us try to put values here to fulfill the demands of shops. For this first cell, we will send 2 units so that the demand of shop 1 is fulfilled. Now F1 has only 1 unit left because it has a limit of 3 units and we have already sent 2 units to shop 1. so it can only send 1 unit. So we are sending 1 unit to shop 2. Now to fulfill shop 2's demand, we have to send 2 units from factory 2, and here we'll have to send 4 units from factory 2 to shop 3. So this is one solution, and you can see since I have already applied the formula here, it is giving us the value that the total cost I will incur is 54.4. Now instead of sending 2 units from factory 1, if we decided to send only 1 unit from factory 1, so we have 1 unit from factory 1 and 1 from factory 2. Again, for shop 2, we are sending 1 unit from factory 1 and 2 from factory 2. For shop 3 also, we are sending 1 unit from factory 1 and rest 3 from factory 2. You can see still the total cost is 47.5. Is there any solution for which I am sure that it is the minimum cost? To solve such problems in Excel, we use 𝗏𝗏𝗃. 𝗏𝗏𝗃 is available in the data menu under solver. So now let us go to the exercise sheet and solve this problem. First thing I have done is we have added 2 cells here. These cells will actually add the values in these 3 cells. This cell will add the values in these 3 cells, and this next cell will add the values of these 3 cells. And the constraint that will give our solver is that this value should actually be equal to the supply that this factory can actually do. Similarly, for the shops, we will add these 2 cells into this bottom cell and will give the constraint that this value, the sum of those 2, should be equal to this constraint. Now let's start typing is equal to sum of these 3. Now sum from J7 to L7. In this cell we will have sum of J6 and J7. We can drag this also, or we can continue to write it. Let's drag it. And this bottom cell is already containing this formula of sum product. To apply sum product, we write is equal to sum product, and within brackets, we first give the first matrix, then after a comma, we will select the second matrix. So now we will click solver option. The objective cell is the cell that we want to optimize. So the cell is J17. Now we want to minimize this because this is cost to us. So we'll select minimize by changing variable cells. These are the cells that I have marked in green. These are the cells that whose value we can change. Now we have to add constraints. So we'll click add. The first constraint is this value should be equal to J9. You can see this first value is cell reference. This is the calculated value. This is where you applied the sum formula. And this second box is the constraint. And this is the fixed constraint that we have received in the problem statement. So we'll click add here. Next, we will select K8 equal to K9, L8 equal to L9, M6 equal to M7, N6, add, M7 is equal to N7. Another set of constraint is that all these values should be positive. So we will select all these and we will tell it to be greater than or equal to 0. Another set of constraint is that all these values should be integral. So it cannot have values like 1.5 or 2.9. So these should be integer. So we will select that these are integers. Add. I think these are all the sets of constraints. So we will click cancel now. So you can see the objective is set to J17 cell. we have to minimize this cell by changing variable cells J6 to L7, and these are the list of conditions that we have. Now we have to select a solving method because the variables in this problem have a linear relationship amongst them. That is why we will be using the simplex linear programming solving method. So let's click solve now. We want to keep the solver solution. So click on OK. So now these values are actually filled in by the solver. We initially had some other values. Now these values are given by solver and we have a total cost of 38.1. If you remember, initially we had something around 50. Now it is 38.1 and this solution is the optimized solution. So this is how we solve minimization and maximization problems using Excel and particularly using solver in the Excel.